Welcome back to the deep dive. Today, we're getting into something really fundamental for cloud stuff. AWS EC2 instance types. Our mission, basically, is to figure out how you choose the right virtual machine for pretty much anything you do online.
Mm.
Okay, so to make it simple, maybe think of it like renting a car.
Oh, I like that analogy.
Yeah. You wouldn't use a sports car to haul furniture.
Definitely not.
So you pick a compact, maybe a truck, maybe that fast sports car. EC2 instances are kind of the same, different virtual machines, really tailored for specific jobs.
Exactly. Like, do you need a good all-rounder?
Yeah, or like tons of processing power.
Or maybe loads of memory or super fast storage access. There's basically an instance type built for each of those needs.
Right.
And understanding this distinction, it's really, really key.
Why is that? Performance, cost.
Both, yeah. It's all about optimization. Choose the right one, and you avoid, well, paying for power you don't need.
Okay, that makes sense.
Or maybe worse, your application underperforms because you skimped on the resources, right?
Bottlenecks.
Exactly. So getting this right gives you flexibility. It helps with scaling, too, with things like AWS auto scaling.
Yeah.
And, you can run really specialized jobs without needing your own physical hardware.
And AWS groups these, right? They aren't just random names. They call them families.
Families, and each family is really designed with a specific type of workload in mind.
Balancing things like CPU,
Storage,
network.
networking, yeah, they optimize that mix. And the names themselves, like T3.micro or M5.large, they actually tell you something.
Like a code.
Kind of. The letter's the family, T or M, the number's the generation, like how new it is, and that last part, .micro, .large, that tells you the size within the family.
Okay, so let's break it down. First up, general purpose. Sounds like the standard option.
Pretty much. Think of them as your reliable sedan, like you said.
The all-purpose vehicle?
Exactly. They give you a good balance of everything, CPU, memory, network, good for, everyday tasks.
Right. Not too extreme in any one direction.
Precisely. And you've got families like T. Think T3.micro. These are burstable.
Burstable, meaning?
Meaning they handle spikes in load well. Perfect for, say, a small website or blog like a WordPress site where traffic isn't constant. But here's a common mistake. People use them for jobs that need high CPU all the time.
And then?
They get throttled. Performance tanks. So for more consistent needs, you'd look at the M family, like an M5.large. Steady, reliable performance.
Okay, so if general purpose are the sedans, compute optimized must be the sports cars, all about speed.
You got it. Pure processing power. These are for tasks that are really CPU hungry.
Like what kind of tasks really push these?
Oh, things like complex scientific modeling, batch processing, or even busy multiplayer game servers.
Game servers, okay.
Yeah, the C family, like a C5.large or C5.x large. A gaming company might use that C5.x large to make sure the game runs smoothly, lots of players, real-time action. CPU is just critical there.
All right, moving on. Memory optimized, the moving vans, you call them, big RAM.
Yeah, exactly. Huge cargo space for data and memory.
Have you seen systems just grind to a halt because they ran out of RAM? Even with a decent CPU.
No, absolutely. It's a classic bottleneck scenario. These instances are vital for anything doing lots of in-memory work. Big caches, large in-memory databases, real-time analytics where you're churning through tons of data fast.
Yeah.
So you're looking at the R family like R5.large or even the X family like X2GD.medium for, well, truly enormous memory needs.
Wow.
Think of a financial firm using an R5 instance for real-time stock analysis. Needs that data in RAM for instant insights.
Okay, last category, storage optimized. The delivery trucks. Fast loading and unloading.
Perfect description. These are all about high-performance storage, usually directly attached, super fast reads and writes.
Oh, data-heavy stuff.
Definitely. Think databases, data warehousing, log processing. The I family, like i3.large, gives you extremely high I/O, often using NVMe SSDs for low latency.
NVMe, right, very fast.
Very fast. Then there's the D family, like D3.x large, which is more about dense storage, packing lots of data cost-effectively.
So an example for the I family.
Maybe a company running a busy NoSQL database like MongoDB on an i3.large. Those fast local SSDs just chew through the read-write operations. But the real magic, I think, happens when you see how these different types work together.
Building a whole application.
Exactly, like an e-commerce site. They might use, say, general-purpose instances for the main website that customers see.
Okay, makes sense. Balanced load.
Then maybe compute optimized for their back-end inventory processing that's heavy CPU work.
Right.
Perhaps memory optimized for a real-time recommendation engine crunching user data in memory?
Ooh, clever.
And finally, storage optimized for the main customer transaction database needs fast, reliable storage.
Just you mix and match.
You mix and match. Tailoring the instance to the job maximizes performance and keeps costs down. You avoid that clunky, expensive, one-size-fits-all mistake.
So wrapping up, it seems like really understanding these EC2 instance types lets you pick the absolute right tool, the right virtual machine for whatever you need to do.
Efficiency and cost-effectiveness.
Exactly. Which leads to a final thought for you listening. Now that you know a bit more about how these virtual engines get chosen, how might that change how you think about how responsive your favorite apps are?
Okay.
Or even, the cost behind all the digital services you use every single day. Something to think about.